equal payment compound amount. In this type of investment mode, the objective is to determine the future worth F of equal payments A which are made at the end of every interest period till the end of nth interest period at an interest rate I compounded every period. The cash flow diagram of this investment type is: you have a timeline, you have an equal payment at the end of every interest period. This payment is also known as annuity. For this payment, we are supposed to determine what will be the single future worth after nth interest period at an interest rate I. The mathematical representation of this situation is known value of A with F, which is unknown, with I interest rate and N interest period. The term F slash A I N is called equal payment compound amount factor. The formula to obtain the equal payment compound amount is F is equal to A into 1 plus I to the power of N minus 1 divided by I. Here I is in terms of decimals.
Now let's solve a problem on equal payment compound amount. Lata is planning to buy a car. She plans to divert her savings of rupees 40,000 as investment every year for next 10 years. The bank gives 12% interest rate compounded annually. Find the maturity value of her account after 10 years. So this is the question what we are having now. So Lata is planning to purchase a car. So what she is going to do is, she is getting a savings. She is having a savings of 40,000. So every year she is depositing 40,000 into her bank account for 10 years. And this bank is giving 12% interest rate for that particular deposit. So we want to now calculate how much she is going to accumulate after 10 years. So we'll solve the problem now. The solution. Given data, so first thing is the fixed annual investment. Fixed annual investment, which is denoted as A. So please make a note, A is also called as annuity. The fixed annual investment is also called as annuity. So which is rupees 40,000. Next, interest period. Interest period, which is denoted as N, is 10 years. Interest rate, which is I, is 12%. So I am converting this percentage into decimals now itself. 0.12. Now we are supposed to draw the cash flow diagram. So again, as usual, you have a timeline with cash inflows and cash outflow. So cash inflow, cash outflow, that is timeline. Again here the investment is of 10 years. So we'll draw the timeline. So it starts with 0, 1, 2, 3, 4, 9, 10. You can draw the full time scale, but I don't have enough space. That's why I have shown the continuous mark over here. So what is happening now? So the payment is not from time t equal to 0. She will be investing after 1 year. So that you need to remember in equal payment. So always the equal payment or the annuity starts from the end of first year. So Lata is planning to divert her savings. Since she is diverting her savings, the amount is she is transferring from her account to the bank's account. So the money is going from her account to the bank account, therefore it is a cash outflow. So she is diverting a constant sum of 40,000 rupees, which is constant, every year up to 10 years. So even at the end of 10th year, she is going to invest. So all this is a common sum, which is rupees 40,000. So this is a given data. Now you are supposed to determine the maturity value of her account. That means after 10 years, how much money is coming into her account. That is the cash inflow. We are supposed to determine the cash inflow, which is F. That is the future value of this particular investment. So F is what we are supposed to determine. So equation for this is single payment future amount, single payment future amount, or maturity value, they both are same, which is F is equal to A into 1 plus I to the power of n minus 1, this divided by I. So this is the equation, A multiplied by 1 plus I to the power of n minus 1 divided by I. Now let's substitute this particular value. So I'm substituting it over here. F is equal to, A is the annuity or the fixed annual investment, which is 40,000. So 40,000 multiplied by, I'll put a big bracket, 1 plus I is the rate of interest in decimal, which is 0.12 to the power of n. N value is 10 years minus 1, this divided by value of I. So again I is 0.12. So which is equal to 40,000 multiplied by the value of this particular term. Now we'll calculate what is the value of this term. Okay, we'll now calculate it. Brackets open, I'll put double bracket, 1 plus 0.12 to the power of 10 minus 1, I'll calculate it, divided by 0.12, which I am getting it as 17.548 or 549. I am rounding it off, 17.549. So I'll write down this value. The value is 17.548, which is equal to, I'll multiply these two terms. We have 40,000 multiplied by 17.548, which is giving 7,01,920 rupees. The future value F, or the maturity value F, is equal to rupees 7,01,920 only. So if Lata is planning to invest 40,000 rupees every year into the bank, which is giving 12% rate of interest, so she will be having 7,01,920 rupees after 10 years in her account.